Our next unit of study in Algebra 2 is going to be the use of matrices. Now we're going to begin this with looking at some terms and definitions to help us to describe the matrix. And some of this will be reviewed from items that we've learned earlier in our course of study. So first, what is a matrix? A matrix, simply put, is a rectangular array of numbers. Now this array of numbers is bracketed on either side as such, and can be just simply 1, 2, 3, 4, 5, 6, 7, 8. And what composes the matrix is a series of columns and rows. And when we start talking about matrices, we have to talk about their dimensions. So a dimension is the number of rows and columns in a matrix. The matrix shown above is 2 rows and 4 columns. If we were to give this matrix a name, such as A, we would say A is a matrix that is This matrix is a 2 by 4 matrix because it's 2 rows and 4 columns. And it always goes in that order: rows first, columns next. Now, next is element. And an element is a single number in the matrix. Now, we refer to the matrix with capital letters. We refer to the elements in it in lowercase. So if I was to talk about a single element, such as A 2, 1, I'd be looking at the second row, first item in that row, so that would be element 5. And matrices are listed on this way. Sometimes it has a comma there, oftentimes not, but then it gets confusing when you have more than 10 rows or columns for getting things going. Last, we come to corresponding elements. And these are elements in different matrices that are in the same position. When we go to be doing our arithmetic with the matrices, adding and subtracting, we're going to add items in corresponding positions. So let's take a look at how we do this adding and subtracting of matrices. Now, in order to add or subtract, as was just stated, the matrices have to have the same dimensions. So in order to add two matrices, they have to have the same number of rows and the same number of columns as each other. So these two matrices, matrix A and matrix B, are both 2 by 3s. That is because each of them has 2 rows and 3 columns. So I'll say A is a 2 by 3 matrix and B is a 2 by 3 matrix. So now what we're going to do is we're going to go through and do some arithmetic. First, we're going to do A plus B. And what this works out to is we start by copying down the matrices themselves, and with that include our operation. So A plus B, we're going matrix A plus matrix B. Now, in order to get our answer, what we're going to do is we're going to add corresponding items. We're going to start in matrix A with element 2, or item number 2, and we're going to add to that its corresponding element from the next matrix, which is negative 4. Then we have negative 7 plus a negative 1, and we have negative 1 plus 8. Second row, we have negative 4 plus 0, we have 3 plus 6, and we have 1 plus 12. Now going through and simplifying this, I'm going to end up with the following matrix. 2 plus negative 4 is negative 2. Negative 7 plus negative 1 is negative 8. Negative 1 plus 8 is 7. Negative 4 plus 0 is negative 4. 3 plus 6 is 9. 1 plus 12 is 13. So when I add matrix A to matrix B, I end up with this matrix as a result. Now, what if I were to want B minus A? Well, we start by copying down our matrices, along with the operation sign between them. Now, as I was copying this one, I realized that when I copied matrix B for the first problem, I forgot the negative sign right here. So I've gone through and added that into each part of the problem, and that last element becomes a negative 11. But now, going through and subtracting these two matrices, Being able to add or subtract integers becomes very important. So negative 4 minus 2 is a negative 6. Sorry, let me go through and show where I got that from. Negative 4 minus 2 is a negative. Then we have negative 1 minus a negative 7. We have 8 minus a negative 1. Next row we'll have 0 minus a negative 4. We'll have 6 minus 3. We'll have negative 12 minus 1. Now simplifying, again, negative 4 minus 2 is a negative 6. Negative 1 minus a negative 7 is positive 6. 8 minus a negative 1 is 9. 0 minus a negative 4 is 4. 6 minus 3 is 3. Negative 12 minus 1 is a negative 13. So when I subtract matrix B minus A, we end up with the matrix negative 6, 6, 9, 4, 3, negative 13. And when we have matrices, the same properties exist as happened with real numbers. So addition is commutative, subtraction is not. If I were to go matrix A minus matrix B, we would have a change in the difference. So as we go through and work with these, we can actually use the matrix to solve equations for missing elements, which we will get to, or an entire missing matrix using addition or subtraction. So let's take a look. Here I have a matrix, 8, 2, 7, 3, 1, negative 6. I'm adding an unknown matrix B, and I'm going to equal out to be 10, 6, 1, 2, 5, negative 4 in my resulting product, or my resulting sum. So when I design the matrix that I am solving for, I start with a 2 by 3, I end with a 2 by 3, so that means matrix B has to equal a 2 by 3 matrix. And what we're going to do is we're going to go element by element and find the missing pieces. So if I start with 8, I'm going to add an unknown number and end up with 10. Well, 10 minus 8 is equal to 2. Next, I'm going to start with a 2 for matrix element 1, 2, and I'm going to end with a 6 through addition. That means that I added a 4. Next, I have 7. I'm going to end with 1 through addition. That means what I added was a negative 6. And so it will continue. Start with 3, end with 2. That means I added a negative 1. Start with 1, end with 5. Then I must have added a 4 to it. And start with negative 6, end with negative 4. Then I had to have added a positive 2. So matrix B, in order to have this equation be true, is 2, 4, negative 6, negative 1, 4, 2. We can solve for an entire missing matrix in this manner, or we can solve for an individual element. So we're going to find the values x and y for the following matrix. And when we solve these, we're going to pull them out piece by piece. So what I have is I have an x here in my first matrix. I'm going to underline the corresponding elements and pull that out as its own equation. So I have 2x minus 1 equals 7. Solving this for x, I would add 1, so I have 2x equals 8. Dividing by 2, x equals 4. Now going and doing the same thing for y, I have a y in this position in my second matrix, so pulling the corresponding elements, I have 9 minus y equals 4. Solving, I'd have negative y equals a negative 5, so y equals 5. So I was able to solve a set of equations looking for different pieces, all in the same matrix setup. So being able to work with matrices is simply being able to basically work with a table of numbers and find what's going on in that table. So make sure you understand how this works. This is going to be our starting point, adding and subtracting, as we look into matrices through this unit.